ഹലോ ഫ്രണ്ട്സ്, എല്ലാവർക്കും എഡ്യു ലേണിംഗ് പ്ലാറ്റ്ഫോമിലേക്ക് വീണ്ടും സ്വാഗതം. അപ്പോൾ പരീക്ഷയുടെ ഡേറ്റൊക്കെ വന്ന് ഇരിക്കുകയാണ്. അപ്പോൾ പുതിയ ഭാഗങ്ങളുടെ ക്ലാസ്സുകൾ എഡ്യു ലേണിംഗ് പ്ലാറ്റ്ഫോമിൽ തുടർച്ചയായിട്ട് അപ്ലോഡ് ചെയ്തുകൊണ്ടിരിക്കും. അപ്പോൾ എല്ലാവരും അത് കാണുക. പിന്നെ ഈ ചാനൽ ഒന്ന് സബ്സ്ക്രൈബ് ചെയ്തേക്കണേ. Let's discuss about spectroscopy. Spectroscopy is a method of seeing the unseeable. That means unseeable എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ആറ്റമാകാം, മോളിക്യൂൾസ് ആകാം. Using electromagnetic radiation to obtain information about atoms and molecules that are too small to see. ഇലക്ട്രോമാഗ്നറ്റിക് റേഡിയേഷൻ്റെ സഹായത്തോടെ നമ്മൾ ആറ്റത്തിനെയും മോളിക്യൂൾസിനെയൊക്കെ കാണുന്ന ഒരു മെത്തേഡാണ് സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറഞ്ഞാൽ. നമ്മുടെ വളരെയധികം ചെറിയതായിട്ടുള്ള ആറ്റത്തിനെയും മോളിക്യൂളിനെയും വിത്ത് ദ ഹെൽപ്പ് ഓഫ് ഇലക്ട്രോമാഗ്നറ്റിക് റേഡിയേഷൻ വി ആർ സീയിങ് ദം. ദാറ്റ്സ് സ്പെക്ട്രോസ്കോപ്പി. നമ്മൾ ഈ ഒരു ഡിസ്കഷനിൽ നമ്മൾ പഠിക്കുന്നത് വാട്ട് യു മീൻ ബൈ UV visible spectroscopy. UV visible spectroscopy is also known as electronic spectroscopy. ഇലക്ട്രോണിക് സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറയുന്ന സ്പെക്ട്രോസ്കോപ്പി ആണ് UV visible എന്ന് പറയുന്നത്. In which the amount of light absorbed at each wavelength of UV and visible region of electromagnetic spectrum is measured. This absorption of electromagnetic radiation by the molecules leads to molecular excitation. UV visible spectroscopy is also known as electronic spectroscopy, in which amount of light absorbed at each wavelength of UV visible region of electromagnetic spectrum is measured. This absorption of electromagnetic radiation by the molecule leads to molecular excitation. So each sentence is very important, and according to that we have to understand each sentence. എന്താണ് ഇലക്ട്രോണിക് സ്പെക്ട്രോസ്കോപ്പി? UV വിസിബിൾ സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറയുന്നതിനെ തന്നെയാണ് ഇലക്ട്രോണിക് സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറയുന്നത്. ദിസ് ഈസ് ആൻ ഏർലിയസ്റ്റ് മെത്തേഡ് ഓഫ് മോളിക്കുലാർ സ്പെക്ട്രോസ്കോപ്പി. മോളിക്കുലാർ സ്പെക്ട്രോസ്കോപ്പിയുടെ ഒരു ഏർലിയസ്റ്റ് മെത്തേഡാണ് ഇലക്ട്രോണിക് സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറയുന്നത്. എ ഫിനോമിനൻ ഓഫ് ഇൻട്രാക്ഷൻ ഓഫ് മോളിക്യൂൾ വിത്ത് അൾട്രാവയലറ്റ് ആൻഡ് വിസിബിൾ ലൈറ്റ്. Interaction of molecules with ultraviolet and visible light. Absorption of photon result in electronic transition of a molecule. Absorption of photon result in the electronic transition of a molecule, and electrons are promoted from ground state to higher electronic state. Electrons are promoted from ground state to higher electronic state. Then what are the principles regarding UV visible spectroscopy? Basically, spectroscopy is related to the interaction of light with matter. As light is absorbed by matter, the result is an increase in the energy content of the atom and molecules. Beer-Lambert's law. On combining to Beer-Lambert's law, formulate that Beer-Lambert's law can be formulated as log I0 I is equal to epsilon Ci. That's equal to absorbance, capital letter A. ദിസ് I0 എന്ന് പറയുന്നത് ഇൻറ്റൻസിറ്റി ഓഫ് ഇൻസിഡൻറ്റ് ലൈറ്റ്, I എന്ന് പറയുന്നത് ഇൻറ്റൻസിറ്റി ഓഫ് ട്രാൻസ്മിറ്റഡ് ലൈറ്റ്, എപ്സിലോൺ എന്ന് പറയുന്നത് മോളാർ എക്സ്റ്റിൻഷൻ കോഎഫിഷ്യൻറ്റ്, C concentration of solution, L is the path length of sample, A is the absorbance. So log I0I is equal to epsilon C dot I, C into I, that is equal to absorbance. It's an important law in UV spectroscopy. And after all, we can study about what procedure can be take place in the UV spectrophotometer. UV visible light, the wavelength of UV visible light is around 200 to 400 nanometer. വിസിബിൾ ലൈറ്റ് എന്ന് പറയുമ്പോൾ 400 to 800 നാനോമീറ്റർ ആണ് വരുന്നത്. അപ്പോൾ വൺ എമംഗ് ദ ഇൻസ്ട്രുമെൻറ്റേഷൻ കമ്പോണൻ്റ് ഓഫ് UV visible spectrophotometer is monochromator. When light falls on monochromator, by seeing a picture we can see when a light source pass on the monochromator, that means this in monochromator it include entrance slit and dispersion device and an exit slit. This together we call it as monochromator. And when a source falls on monochromator, on the first slit the photon parallelly fall on the prism and different wavelength of VGO can be obtained, and second slit equal intensity of two rays can be obtained. After that we come across a sample, a cuvette is a sample tube is known as cuvette. After sample there's a detector can be placed. So already we know that what you mean by filters, monochromators and all. നമ്മൾ സ്പെക്ട്രോഫോട്ടോമീറ്ററിന് ഉപയോഗിക്കുന്ന ലൈറ്റ് സോഴ്സ് എന്ന് പറയുന്നത് there are various UV radiation sources are used, that is deuterium lamp, hydrogen lamp, tungsten lamp, xenon discharge lamp, mercury arc lamp. ഈ കമ്പോണൻറ്റിൻ്റെയൊക്കെ പേര് വളരെ പ്രധാനപ്പെട്ടതാണ്. deuterium lamp, hydrogen lamp, tungsten lamp, xenon discharge lamp, mercury arc lamp. UV radiation sources ആണ് deuterium lamp, hydrogen lamp, tungsten lamp, xenon discharge lamp, mercury arc lamp എന്ന് പറയുന്നത്. എന്നാൽ അതിൽ നിന്ന് വ്യത്യസ്തമാണ് വിസിബിൾ റേഡിയേഷൻ സോഴ്സസ്. അപ്പോൾ അത് ഇതെന്ന് പറയുന്നത് ടങ്സ്റ്റൺ ലാമ്പ്, മെർക്കുറി വേപ്പർ ലാമ്പ്, കാർബൺ ലാമ്പ്. അപ്പോൾ ഇതൊക്കെയാണ് സോഴ്സസ് ആയിട്ട് ഉപയോഗിക്കുന്നത്. deuterium lamp, hydrogen lamp, tungsten lamp, xenon discharge lamp, mercury arc lamp. ടങ്സ്റ്റൺ ലാമ്പ്, മെർക്കുറി വേപ്പർ ലാമ്പ്, കാർബണേറ്റ് ലാമ്പൊക്കെ വിസിബിൾ റേഡിയേഷൻ സോഴ്സസ് ആയിട്ട് യൂസ് ചെയ്യുന്നുണ്ട്. എന്തൊക്കെയാണ് വേവ് ലെങ്ത് സെലക്ടേഴ്സ് ആയിട്ട് യൂസ് ചെയ്യുന്നത്? വേവ് ലെങ്ത് സെലക്ടേഴ്സ് എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് ആൻ ഔട്ട്പുട്ട് ലിമിറ്റഡ് നാരോ കണ്ടിന്യൂസ് ഗ്രൂപ്പ് ഓഫ് വേവ് ലെങ്ത് കോൾഡ് എ ബാൻഡ്. And two type of wavelength selectors means one it is filters and next one it is monochromator. ഫിൽറ്റേഴ്സും യൂസ് ചെയ്യുന്നുണ്ട്, മോണോക്രോമാറ്ററും യൂസ് ചെയ്യുന്നുണ്ട്. ഫിൽറ്റർ എന്ന് പറയുന്നത് രണ്ട് ടൈപ്പ് യൂസ് ചെയ്യാൻ പറ്റും. ഇൻറ്റർഫറൻസ് filters and absorption filters are used. Interference filters and absorption filters are used. But in monochromators എന്ന് പറഞ്ഞാൽ wavelength selector that can be continuously scan a broad range of wavelength and used in most scanning spectrometers including UV, visible and IR instrument. Maybe it is a prism type or a grating type. Prism type we can use as refractive type or reflective type, and grating type means diffraction type or transmission type. So monochromators wavelength selector that can continuously scan a broad range of wavelength. It can be used in scanning spectrometers including UV, visible, IR instrument. So second component is filters or monochromators. So all monochromators contain following component part. One is that is an entrance slit is there, collimating lens is there, and a dispersing device, a focusing length, and exit slit. And dispersing device, whether it can be a prism or a grating device. So filters, what all things are? Spectrophotometer is a device. It is an instrumentation used in the UV spectrum. And what are the component in the instrumentation? What are the component present in the instrumentation? Source, filters and monochromators, sample compartment, detector, recorder. And what about the sources? Which all sources we used? Sources means we can use whether it is UV radiation sources and visible radiation sources are there. On the various UV radiation sources means deuterium lamp, hydrogen lamp, tungsten lamp, xenon discharge lamp, mercury arc lamp, etc. Whereas various visible radiation, that is tungsten lamp, mercury vapor lamp, carbon lamp, etc. And after that is a filter or a monochromator can be used, and filter it may be interference or absorption, and monochromator can be in two type, that is either it is prism or grating type. And what is the function of monochromator? Wavelength selector that can be continuously scan a broad range of wavelength. And together, what do you mean filters or monochromators contain following parts: entrance slit, collimating lens, a dispensive device, a focusing length, and exit slit. So as far as and next one, it is after the exiting slit there is a sample container or sample cell, that is a variety of sample cell available in UV region. The choice of cell is based on the path length, shape, size and transmission characteristics at the desired wavelength and relative expense. So the cell holding the sample should be transparent to wavelength region to be recorded, and it can be made up of a cuvette. Cuvette means quartz or fused silica cuvette are required for the spectroscopy in the UV region. Quartz or fused silica cuvette are required for the spectroscopy in the UV region. Silicate glasses can be used for the manufacture of cuvette. Which substance is used? Silicate glasses can be used for the manufacture of cuvette for use between 350 and 2000 nanometer. Thickness of the cell is generally 1 centimeter and cell may be rectangular in shape and cylinder on flat ends. So, what is the speciality of cuvette? It is as rectangular in shape and cylindrical with flat ends. Next, after that sample the cuvette, we use the detector. What all detectors are used means after the light has passed through the sample, we want to be able to detect and measure the resulting light, isn't it? Yes, that this type of detectors come in the form of transducers that are able to take energy from light and convert into an electrical signal that can be recorded, and if necessary it is amplified. So detector, it's a common type of detectors are used means one, it is barrier layer cells, second one is photo emission cell detector, and third one is photo multiplier. Barrier layer cells, photo emissive cell detector, photo multiplier. Barrier layer cell, photo emissive cell detector, photo multiplied. Barrier layer cells, photo emissive cell detector, photo multiplier. These are the three types of detectors used in the UV spectrophotometry. And next one is the detector has a thin layer, metallic layer coated with a silver or gold acts as an electrode. It also a metal base plate which acts as another electrode. So we have to study in this topic it's what all detector is used. Barrier layer detector, then photo emissive cell detector, photo multiplier can be used, and the surface of photocathode is based on the layer of elements like CCl, silver oxide, and mixture of them. These photo tubes and photo so which type of cuvette is used? This is a cuvette made up of silica and it is rectangular in shape. Then we move to double beam spectrometer. There are two type of instrumentation can be take place in two type, that is single beam and double beam spectrometer. Depending upon the monochromator, filters or dispersing device used to isolate and transmit a narrow beam of radiant energy from incident light determines whether the instrument is classified as photometer or spectrophotometer. In spectrophotometer, use detects the percentage of transmittance of light radiation when light of certain intensity and frequency range is passed through a sample. Both can be single beam or double beam optical system. Spectrophotometers you used here detect the percentage of transmittance of light radiation when light of certain intensity and frequency range is passed through the sample, and it can be single beam or double beam are used. Single beam is there is only one light beam or optical path from the source through to the detector. When the case of double beam, the light from the source after passing through the monochromator is split into two separate beams, one for the sample and the other for the reference. And mostly double beam is used. And what is the specialty of double beam? The light from the source after passing through the monochromator is split into two separate beams, one for the sample and the other for the reference. Okay, and as far as single beam spectrophotometer is concerned, a single beam of radiation passed through a single cell. The reference cell is used to set the absorbance scale or zero or the wavelength to be studied. Is then replaced by sample cell to determine the absorbance of the sample at that wavelength. This was the earliest design and it is still used in both teaching and industrial labs, but practically this double beam spectrophotometer is used. Double beam spectrophotometer means instrument used in the ultra visible spectroscopy is called a UV visible spectrophotometer. It measures the intensity of light passing through a sample. It measures the intensity of light passing through a sample and compared to the intensity of light before it passes through the sample. It measures the intensity of light passing through a sample and compares to the intensity of light before it passes through the sample. The ratio called the transmittance and is usually expressed as in percentage T. Absorbance A is based on the transmittance. A is negative log percentage T divided by 100. Okay, usually double beam spectrophotometry is used. This is the instrument used in ultra visible spectroscopy, UV visible spectrophotometer. And when we plot a graph between absorption and wavelength, we will get the maximum absorption of wavelength, and from that we can identify the element. When we plot a graph, in y-axis there is absorbance and x-axis is wavelength. We can identify the chemical species on at which point maximum absorbance happens. Likewise, we can identify which compound it is. So UV spectroscopy is very useful to find the concentration of the solution, and in the case of food analysis. So each point is very important. Try to study by watching one or more time and keep watching Edjo learning platform and support me, and it will be a great pleasure to do many more videos. So you can subscribe my channel, hit the bell icon for new notification, then only you will get the notification. So stay safe at home. You can study. Learning is an amazing process. Keep watching Edge on Learning platform. Thank you.